Hey guys, okay, so what we're going to do today is we're going to create a random number generator. We're going to create two little applications. One's a bit kind of game-like and one's a bit demo-like. In this first demo that we're going to create, I'd like you to pop open the Visual Basic 2010 Express and create a form that looks like this. And this is a really simple application. We've only got two form objects here. One's a button and one is a label. If you can get that set up, remember you can pause the video whenever you need to, so I'm just going to forge ahead. Here's our button. I'd like you to call that button get number, BTN get number, following our naming convention as usual in the class, and set its text property to go, right there. And there's our label, and that's going to be named LBL number, and obviously set its text property to number colon blah 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 blah. Alright. So I'm going to switch over to the code view here and show you what's going on. First things first, as always, I'd like you to create your programmer's block at the top. And then what we're going to do is we're going to create a single variable here of type single, and I'm just going to call it SNG sum number, and we're just going to generate a random number, store it in here, and then use that number and spit it out in our label. Okay, so I'm going to hop down into the code here. I'm just going to comment this guy out for a second here because we don't need it right yet. Our SNG sum number is going to equal this funky looking thing here. Now this is called a procedure, and what it's doing is this is going to generate a random number in the range of 0 all the way up to 0.99999 repeater. Now at first glance it doesn't seem like it might be all that useful, but with a little bit of funky math we can actually create a random number in any range that we want, from 1 to 10, from 1 to 100, 1 to 1,000,000, or we could even create a random number from 17 to 942. Whatever random number sequence you want, you can use with a little bit of math, and it's not that complicated math. You can use this to create it. Alright, so I've commented this line out for a reason, and I'll show you why. I'm going to run this, and we'll give it a quick test. Remember, this is going to generate numbers in this range here. Hit the play button, and here's our output. I click go, and 7055475 is the first number it created, and 533424, and 5795186, and so on and so on and so on. And we could hammer this all day long. You're gonna have to. I'm not gonna play with this too long because you're just gonna have to trust me. This is gonna generate a number from 0 on up to that 0.99 maximum ceiling. All right, but what I did want to show you was, watch closely. I'm going to run this 3 times, and I want to see if you recognize a pattern here. So I'm going to hit play. The first number generated is 0.7055475. Hit it again. It becomes 0.533424. Hit it again. It becomes 0.5795186. Okay? See if you can remember those numbers. I'm going to stop this, and I'm going to repop the program. And hit the button again. This looks familiar. 0.7055475. Hit it again. 0.533424. Hit it again. 0.5795186. Okay, just to let you know, I won't even have to run it again. These are the same 3 numbers. And I'll pop it one more time and just go through it quickly. Again, same 3 numbers generated. As a matter of fact, if I keep going, if I'd actually tracked all this, these numbers would be identical every time we run this. So you're saying, Mr. Blake, this random number generator isn't very random. And you're absolutely right. The computer does a very bad job of dealing with anything random. It's not a random device. As a matter of fact, it's quite the opposite of a random device. Computers like things orderly and like things, to be in a certain way. They don't like randomness. So what we need to do is we need to help this become more random by setting something called a random seed. And that's what this guy comes in. And what the random seed is, it really just looks down at your current system clock. And it looks at the smallest numbers, the nanoseconds and picoseconds on your system clock. And that's what it uses to create the random numbers. So this random seed now allows us to use random numbers that are more random. So I'm going to hit the play button, and we're going to hit it here. And we didn't get that 7055 blah 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 number. And these are completely different numbers, and they will be every time we run it. So remember, whenever you use a random number generator, 99% of the time you're going to want to have a randomizer here, and that sets the random seed. Now, that being said, and you only need one of these, you don't need to repeat this any more than once. That being said, there are certain times where you're going to want to have no random numbers. You're going to want that kind of logical sequence. One such time might be, I don't know, let's say you created a video game and you wanted to test certain values. So if you take the randomize out, if you take this out, you're going to get the same sequence of numbers, and you should be able to predict when certain events trigger in a game. I don't know, let's say for example you got Space Invaders moving back and forth across the screen, and they're only going to shoot, 1/10 of the time. If you know what the exact sequence of the random number generator is going to be, you'll be able to very easily predict when they're going to shoot and when they're not going to shoot. So for debugging purposes, it's quite possible you're going to want to take this out. And another possible use, this is a pretty obscure use, you could use the random number generator without this, again, to make your own encryption algorithm, because it will definitely come up with a sequence of similar numbers, or not similar, exactly the same numbers every time, and you can use it to encrypt some data. It's not a great encryption algorithm, but it certainly does work. Alright, so anyways, that's our random number generator. Again, it creates from 0 to 0.9999. Let's make this do something more useful. I'm going to try doing something here. Let's try to create a random number between 1 and 10. So if the lowest number in this range happens to be a 0 and the highest number is 0.9999, let's do this. Let's multiply this by 10. Now what that effectively does is it's going to take whatever the result of this is, whatever the thing is in this range, and it's going to move this decimal over one place. So if it happens to create this number, for example, it'll go from 0.99999 to 9.99999. And that's almost what we want to create a random number in the range of 1 to 10. So the only time it won't create anything in that range is when it creates a 0, which is too low. So what we're going to do is we're going to simply add 1 to this, put a +1 there, and now we've got a random number generator that will create a random number in the range of 1 to 10. Now this isn't a very good way of doing a random number generator, and I'll let you know that what happens when we do this. I'm just going to do this, and I'm going to make this into an integer. Let's typecast it into an integer. So again, we've created a random number between 0 and 0.999. This moves the decimal place over 1, so then we get a random number in the range of 0 to 9.9999. Adding 1 to it gives us a random number in the range of 1 to 1.999999. And by stuffing it into an integer, what we're doing is we're effectively getting rid of the decimal place. So this will create random numbers between 1 and 10. However, this doesn't do a very good balanced job. If you ran this particular number generator, let's say 1,000 times, the number 1 and the number 10 would appear exactly half the number of times as the 2, 3, 4, 5, 6, 7, 8, and 9 numbers. And that's because of round off. It does some funky stuff with that. But anyways, for this quick demo, let's give it a run here. Make sure we test it out. And we'll bring this down to the middle here. 10, 6, 4, 1, 2, 10. So if I can get a 1 here, I got a couple of 10s. Oh, there was a 1. Alright, we're good to go. So this will give you a random number in the range of 1 to 10, but again, the two fence posts, the 1 and the 10, don't appear very often. If you want to get random numbers that appear as frequently across all numbers in the range, you got to use a formula that looks a bit like this. I'm just going to reduce the size of the font here. Let's go wrong way. There we go. So again, we're typecasting into an integer, and what we're going to do is we're going to put the highest number in the range that we want there, subtract from it our lowest number, so the highest number minus lowest, add 1, multiply it by a random number generator, and then add our lowest value at the end here. Seems a lot more complicated than it really is. So let's do that here. Int, open bracket, let's say our highest number is 10, minus our lowest number, which is 1, plus our lowest number, or plus 1, sorry, not plus the lowest number. There. Close the brackets off. Multiply that by our random number generator. Close the bracket off again, and then add 1. This, just like that previous line, creates a random number between 1 and 10. However, our 1s and 10s will appear as frequently as all the other numbers in the range. So we start hitting that. 10, 1, 10, Test, 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 test. Everything looks to be working fine. Alright, so let's just do one more thing here. Actually, no, we'll do it on the other one. So, got to remember this formula, guys. Most important things you can remember from this particular tutorial are this. Number one, got to have the randomized. That sets your random seed based on the current system clock. Number two, type out that formula, put it in your comment marker so you can have it forevermore. I always forget it. Every time I do this, I have to re-look this up because I'm old and I can't remember these things. Alright, so again, highest number minus lowest number times your random, and then add your lowest value there. Convert the whole thing to an integer, and it truncates the decimal at the end, and you're good to go. Alright, so that's that. I'm going to close this off, and let's have a look at the other one.